Right. Thank you very much, Professor Reddy, for that nice introduction. And it was indeed a pleasure to interact with you during your presence in IIT and in Chicago. Um, I hope you're all able to see my screen.
Yeah, all good. It's nice.
Oh, wonderful. So I'll quickly move on to the presentation. Please feel free to raise your hand if you want to get some clarification in between. And also there is a discussion time at the end, right? So
Yeah,
that
yeah.
can happen. Yeah. So you must be wondering, many of you may not be familiar with the acronym NAPL. Um, uh, it's not very commonly used, at least in India. Those who are in the Western countries, you may be quite familiar with this acronym. NAPLs is not a new contaminant. It is just an acronym for non-aqueous phase liquid. And as the name indicates, these are liquid, but they are not miscible in water. So they coined the phrase terminology non-aqueous phase liquid. So I got introduced to it during my PhD days and have been working in this area ever since. Uh, Even though I have moved on to other areas also, this has always been a part of my research ever since I spent my PhD. It is in 2000. So this illustration here kind of depicts what happens when a non-aqueous phase liquid. To make it simple for you, the closest we use every day is petroleum as a fuel, right? Your petrol, diesel, they're all coming under this non-aqueous phase category. Okay? So spills happen wherever petroleum is being handled. We see spills happening. Some are reported, major ones are reported. A lot of minor spills go unreported. And the science of understanding these spills and its impact on the environment has been around for a very long time, at least 70 years, as far as I know. So, uh, in India, I find that there is still a lack of research in this area, understanding the transport, transformation, and then even remediation. It's been in a very, very nascent stage, although we are having these issues in India. So that is something which I want, since majority of the audience I see are from India, this will be a good opportunity to sensitize you on this very, very important environmental um, problem, which is all around us, yet it is invisible. Okay, so this is a scenario where a spill occurs. No? It can be a petroleum spill or any other NAPL, and on ground and it moves down. This is the unsaturated zone, so it can move down readily until it reaches the water table here, and then since it is lighter than water, particularly there are NAPLs can be heavier also. Certain NAPLs like solvents with a higher density than water, that's a much bigger problem. For now, let's focus on the lighter non-aqueous phase liquid. And this is a scenario which typically happens below ground. It floats on top of the groundwater table. And so when you're drilling wells around the spill site, you will definitely hit petroleum. Okay. And then you will only reach the groundwater below that. Okay. So this is a simple depiction of a spill site, just to give you an idea. So, yeah, summary is here. NAPL is non-aqueous phase liquid. Petroleum compounds, organic solvents come under this category. They're immiscible, and but they have very low solubility. They are not insoluble. They are very low solubility, and that is the problem. So even at that low solubility, even if it is like 1 or a few milligram per liter solubility, it poses a huge health risk to humans and other life forms because of the toxic nature of these chemicals. And so they are a long-term source of contamination because their solubilities are so low. It takes a very long time for this petroleum to disappear if it is only dependent on dissolution. And there can also be volatilization. Many of the petroleum compounds are volatile, so that also poses a health risk, right? The petroleum vapors are inhaled, it causes a lot of serious health risks, including lung cancer, leukemia is also reported when you are exposed to petroleum compounds. So, potential carcinogen or affect central nervous system. Where do we find them? No, it's not too far away from us. Everywhere, anybody who is living in a big metropolitan city, there will be uh, pipelines because every street, every major road has petrol bunks, right? Petrol stations where you go and fill up your petrol, right? We all want it more and more closer to our homes. You don't want to drive too far away, several kilometers. So it's coming closer and closer to home. Just your petrol bunks can be a source of spill. Uh, then there are large storage terminals where the city stores the petrol and then distributes it to us. Then there are refineries. In major cities, we have refineries, Chennai, we have Manali, we have Cochin refinery, we have Mangalore refinery, everywhere, Gujarat, yes, there are refineries. And there are pipelines taking these products. No? The crude, of course, whenever you have a port, there is import of petroleum crude and sending the refined products out. So port is also an important place where these spills occur on a regular basis. Now, so starting from drilling sites to ports to pipelines, terminals, refineries, a potential spill. They are potential spill sites, and often spills are happening in these spill sites. When you look at other non-petroleum NAPLs, chlorinated solvents are a huge environmental problem because again they are carcinogenic. Dry cleaners are a source of chlorinated compounds, and other chemical industries, pharma and pesticide industries, they all use solvents a lot. So they are all potential areas where spills are happening or probably could happen. So it's all around us. Okay. Unfortunately, we don't really we are not aware of the problems of these kind of compounds. And the other thing which most of us don't, when we talk about oil spills, everything which comes to our mind is an ocean oil spill, right? We have seen images of that. But we don't even imagine an oil spill below us, below the ground, in your groundwater. Unfortunately, if you look at the statistics, the marine facility spills happen only 29% of the spills reported are only marine or in the ocean. Most of the other spills are happening inland, pipelines, transportation on land, and fixed facilities like refineries and storage. Right? So 71 percentage of the oil spills are happening inland, and so there is a potential for soil contamination, groundwater contamination, and human exposure, direct human exposure. And of course, the frequency of spills are also more during transportation. Fixed installation is the highest, like oil terminals and petrol bunks. Okay, and impacted areas, roads, inland waterways, marine waterways. Okay, so these are all reported data. And major spills have happened in inland areas, some in the US, Kuwait, okay, and Katrina, during the Katrina the storm. And many have reported in India, uh, but the news is not quite, doesn't take a prominent space in the media in India, and because there's no follow up, and so the news, people forget the news. They just read it. There's no follow up, and these are hotspots in India where we have refineries and a lot of oil is handled in coastal areas where the ships arrive and leave with the petroleum products. Okay? And so these images are actual spills which happened right in Chennai, where this is a lube oil spill and this is a fishing community. So they stopped selling fish and they started selling lube oil because they found lube oil in their waters. Okay? So sad, funny, but sad. And petroleum pipeline spills are very common. This whole area, Coast, north of Chennai, is the hub for industrial activity. And so there's a lot of pipeline spills happening on a very regular basis. And 2013, there was a major spill uh, in in very close to these refinery areas, where people could actually take the water from their bore well and they could use it in their TVS 50, or they could even, this lady is demonstrating their water taken from their bore well is burning, right? So it's people were quite happy initially, but then they realized it's a huge problem because their groundwater was contaminated. And these you see in drilling sites, uh, but very, very recently, just a month ago, in Chennai, there was a huge spill because of the cyclone, the recent cyclone, Migchong cyclone, which happened in December, early December 2023. There was a huge spill, oil spill, which happened in Chennai, again in the same industrial area. Along with the flood waters, there was a flood of oil coming out 12 kilometers of the river, travel 12 kilometers through the river and reach the ocean. And so all along there was like huge amount of oil deposits on the banks of the river, on the it entered homes. Wherever there was a breach, it entered homes and please mute your mics. So it entered homes and it became, and then it came to the news. And then there was investigation. Our team went out for the investigation for 2 weeks and we found a lot of damage, ecological damage, birds, fish. There were huge mangrove forests in this river, along the banks of the river and the island of the river. And so everywhere there was oil. This is we tracked the path of the spill and it eventually reached the ocean at the Ennur Creek. So this was one of the major environmental above ground disaster which has happened in recent times. This is a snapshot of the mangrove forest where you can see up to 8 feet of the mangrove is impacted by the oil. The flood water rose up to 8 feet, carrying the oil with it. And so there was a huge impact on the mangroves. That is where the birds, the turtles, and the crabs, they nest in these mangroves. And so this ecosystem is going to take several years to be recovered. So it's a serious problem. And I think wherever oil is handled, we all have to be aware of this problem and a little more science I'll be talking about later to understand what happens when these spill occurs. Okay, so, yeah, this is not the only thing. I think solvents are handled in many, many industries, like I said, and due to lack of monitoring, there has been a lot of spills across India. If you look at CPCB website for critically polluted industrial clusters, you will find all this data. Okay, they've identified 10 prominent sites where chemical spills have happened and they are waiting to be remediated. Although the government has recognized that there are 300 plus sites across India, they are yet to be remediated. Okay. Whereas if you look at the same scenario in Western countries, already several 100,000 sites have been remediated once it is identified. We need to bring those mechanisms in place to India so these sites can be remediated. And so we have, as academicians, we all have a role to play in trying to create awareness, develop skill sets, and then try to work with the government to remediate these sites. So some of the snapshots of other sites, I'm not going to dwell too much onto this. Kodaikanal, again in Tamil Nadu, there's a mercury spill site, the thermometer manufacturing facility. 20 years ago, they shut it down 30 years ago because of this huge spill of mercury. And we all know mercury is a very, very toxic chemical, again, neurological damage, Minamata disease, and all that. This is another leather belt of Tamil Nadu, Vaniyambadi and Ranipet area, where there was hexavalent chromium, which was spilled. These are not NAPL spills per se, but there are also solvent spills associated in other places like Union Carbide. We know it is very, very notorious for the Bhopal gas tragedy. But beyond the gas tragedy, there was also a chemical spill. All the solvents which were used in the premises were abandoned. Since the entire factory was abandoned, these are the solvent storage facility now rusted, and all the solvents went into the groundwater, and people are suffering from groundwater contamination even now. So there has been 2010-11, as I told you, CPCB started documenting contaminated sites, and so the future is quite positive in the area of chemically contaminated sites, and uh, remediation is there is a possibility of remediation happening in India. So this talk probably is at the right time where we need a lot of capacity building in our country to deal with such contaminated sites and understand, do some assessment, modeling, and then also do some remediation. Okay, so just to a little bit of science, I talked about these NAPLs not being uh, miscible, right? So they're not going to dissolve like your. We regularly deal with other contaminants like nitrate is a big problem from fertilizers. Then there are other miscible contaminants, fluoride, arsenic. These are all the common groundwater contaminants we talk about, which are miscible. But when they are not soluble, we should understand, or it is very slowly soluble, very low solubility. There are other factors which come into the picture. When in the case of miscible contaminant, we have these nice groundwater transport equations, right? Advection, dispersion, diffusion, and we can include some sorption. So several analytical models exist, and there are also mathematical like models and softwares which can predict these contaminant plumes readily. Okay, but it becomes a little more complicated when uh, oil spill has to be modeled in a groundwater environment. Right. So first of all, oil is going to be trapped. It's not as readily mobile, and then it can actually affect the permeability, right? We all know about permeability, hydraulic conductivity, uh, but when there is oil trapped in the soil, the permeability gets affected. So what is the new permeability? There's a terminology called relative permeability comes into the picture. So it depends upon the amount of oil which is trapped, and so we need to know how much is trapped, where it is trapped, and how the flow is getting modified, the relative permeability changes happening in the spatially in the aquifer. So there will be bypassing. Wherever there is an oil, the water cannot flow readily, and so there will be bypassing, just like what happens in rivers, right? So groundwater also there will be bypassing of flows. So a little more complex phenomenon is happening, and we need to understand all that with science. Okay, so how understanding oil entrapment is the first step. So when there is a spill, and as the spill moves through the ground, the oil is getting trapped, right? So just like when we have water You don't get all the water when you pour water, and at the bottom, you don't get all the water, right? There is some residual saturation which is trapped because of the capillary force. Similarly, oil also gets trapped, and that is called the residual oil in the soil. Okay? So when there is residual oil, like I said, there is a pore space is getting occupied, the permeability gets reduced, hydraulic conductivity gets reduced because the oil is blocking these pore space. Okay, and we can do experiments in the lab to understand the permeability, reduced permeability, similar to your capillary pressure saturation curves. We do it with air and water experiments. Same thing we could do with the NAPL and water. Okay, so in this case, we have illustrated a capillary pressure and saturation experiment with mercury. We was understanding what is happening in the Kodaikanal site. So what you see here is in the silver form is the mercury. We have entrapped mercury. Mercury flows from bottom to top, and then once it is entrapped, we start doing the permeability experiments to understand what happens to the permeability. So this is the entrapped mercury after the flooding of mercury and draining. Um, and we plot these pressure saturation curves to understand what is the residual saturation. And these experiments can be done for any solvent, petroleum or whatever solvent is of interest, and understand what is the saturation of the oil or the mercury or any NAPL in the water, in the soil phase. Okay, so very basic physics of flow. This is two-phase flow phenomenon where there is NAPL and there is water flowing in the same pore space. They compete with each other. And terminologies like wettability come into the picture. So if the soil is natural soil is mostly water wet, okay, so you'll see the wettability, the contact angle is acute here, whereas when it is NAPL wet, these are more to do with the surface of the soil. Petroleum engineers and they understand this a little better, but these are simple terminologies we can also pick up. So whenever it is an obtuse angle, we call it a NAPL wet condition. Okay? So water wet condition, the NAPL gets entrapped. They don't move. They're not so mobile. Whereas when it is oil wet, then the oil is free to move. So the same, some of the basic physics, capillary pressure and relationship of the capillary pressure to the pore size. This is well-known theory of your capillary pressure and radius of your R indicates the pore size. Okay, so we use those simple uh, expressions to, so whenever there is a coarse sand, the R is going to be more and your capillary pressure is smaller and vice versa. So in a fine grained sand, you're going to have less amount of, the NAPL is going to find it difficult to move, whereas in a coarse grain sand, you're going to have a NAPL movement faster. And again, there is a lot of entrapment happening in the coarse layer. So when there is a heterogeneous system like a natural aquifer, you'll find more entrapment in the coarse sand, whereas in the fine sand, there is going to be minimal entrapment because your R is small and your capillary pressure is high. The NAPL cannot percolate the fine lens, and so it is pooling here. Okay, so basic science. I'm not going too much into it. So you'll find a range in a petroleum spill site. You'll find a range, different forms of petroleum entrapped in the coarse lens, petroleum pooling as large pools above the fine lens, and a lot of fine residuals in the fine lens. Okay, a variety. And on the this is actually for a dense NAPL, when the NAPL percolates even the water table, right? When it is a lighter NAPL like the one I showed in the first picture, you'll only find a pool of NAPL. okay, floating above the water table. So as I told you, dense NAPLs, it is more complicated because it penetrates the water table, and until it reaches, until it all gets entrapped, you'll find them all over the aquifer. Okay, so there can be different pathways. In a fissured formation, it goes even deeper. And this is, sorry, I think there is some overlap here. So again, this shows how, as the water table moves up and down, the pool of NAPL gets entrapped more and more as it goes into newer areas of the sand. And so it becomes a bigger problem when large areas of the aquifer is now exposed to the oil. So we understood the entrapment. We should also understand what happens after entrapment. As I told you, the NAPL dissolves at low rates. And there are also other physicochemical phenomenon which happens for any contaminant, right? If it can be oxidized, if it is an oxidizable compound, or it can be reduced if it can only go through reduction, like chlorinated solvents, right? Or biodegradation. We know that microorganisms are plenty even in the aquifer. And so the top layers, you will have aerobic biodegradation, bottom layers, anaerobic. There can be co-metabolic transformations in chlorinated solvents, reductive dehalogenization also in chlorinated solvents. So lots of all the chemical physical transformations which we have studied for any other contaminant can also happen in a NAPL contaminated aquifer. Okay, so this is an actual data from our research to show how the permeability of the aquifer changes over time. So earlier I had showed you how the permeability changes over space, coarse sand and fine sand. Okay, but not only that, once the NAPL starts dissolving, right, the pore spaces which were occupied by the oil, slowly as the oil shrinks, it now allows water to go through, right? So this is what is depicted here. Initially, there is no water going through because this soil is filled with oil. It can bypass, but with time you will see more of the water can penetrate this lens of coarse sand, and that is what is depicted here. So there is a huge range of permeability. If you're going to do some modeling, you can't just use one K value for modeling this flow of water with just one K, one permeability. Permeability changes with time, with space and also with time. So it's more complex. Okay. So I think I'll skip this. There's too much of information. Moving on, I would like to talk about we have understood the NAPL percolation, we have understood the transformations which happen, um, and then comes the remediation. So what kind of remediation can be provided in a contaminated system? So there are, again, depending upon the chemical which is spilled, a lot of different remediation options are available. But you have to keep in mind that during remediation, you are not just worried about the water alone, you should also be worried about the soil, because water and soil are coexisting together along with the contaminant, which is your NAPL, right? So we have to, just cleaning up the water is not enough, because the soil is going to be releasing these contaminants constantly into the water phase. So as the best thing is to do is to clean up the soil, and so then the leftover water can be cleaned up, and then it will be a permanent solution. Sometimes it's possible, sometimes it is not, depending upon how deep the contamination is. If it is just a shallow contamination, you can just excavate the soil and get rid of it, and then go down and clean up whatever the water which is contaminated. For deeper aquifers, it's more complicated. Okay? But this is what I wanted to show, a simple illustration of a remediation by soil flushing. So they just flush out the contaminant, which is highly soluble, highly miscible contaminant. You can do this. You apply water. You know that this site is contaminated, and then you pass a lot of water, pump a lot of water through it, and you make sure that you collect this contaminated groundwater, which is flushing all the contaminants, and okay, you treat it above ground. Then comes when there is a large spill, okay, we have to make sure that the source is removed first. Whether it is a large or small spill, I think the immediate thing is to remove the source. Okay, so this is a plan view. This is the source of the contamination, and this is a plume of contaminated groundwater going out from the source. Of course, the central area will be the highly concentrated contaminant zone, and then the periphery. Okay, so generally there is a lot of options which they do for treating this water. One thing is pump and treat. As you pump out the water and treat it, slowly the contaminated area or the plume will start shrinking. Okay, and if you want to cut off the source, you put a barrier here, and the barrier retains the contaminant within this area, and you start pumping the the contaminated groundwater and treat it. So it's much you stop further contamination of the groundwater by doing this phenomenon. And then these are different arrangements. If there is a wider plume, you can't put a very wide barrier. It's cost, again, cost factor should be taken into consideration. So they do this funnel and gate arrangement where they have like a funnel the plume and then have a smaller barrier and then take care of the contaminant downstream. So containing the waste, the source is a challenge. It is done using civil structures like slurry wall. So if there is a sludge sitting in an industry which is releasing a lot of contaminants into the groundwater, they put a slurry wall which is keyed into the floor. If your confining bedrock is shallow, it is an easier job, and you just cap it, and then you take care of whatever downstream contamination previously had happened. You just take care of it. That's a simple way to stop the source from releasing it. Deeper aquifers, the slurry wall cannot be keyed in all the way to a deeper confining bedrock. And if it is a NAPL, which is just floating on top, you don't have to do it anyway. So it's a hanging slurry wall. And so you just make sure that the contaminant is not moving and the slurry wall stops it, and then you try to deal with the problem upstream. There are other ways of containment of the waste or preventing the waste from contaminating the groundwater downstream. These are different options, right? These are the slurry wall, complete encirculating the waste. And here it is only partial depending upon the plume width. You can decide on the slurry wall length. Okay, so a lot of slurry walls are made with different materials. Cement, soil, bentonite is the cheapest. You know, it can reduce the permeability to 10 power minus 7. The cost is also very reasonable. But cement, bentonite, slurry walls are there. Okay, so that is the other thing is, uh, yeah, these is more practical applications of the slurry wall construction. The backhoe uh, trench, a trench is dug using a backhoe, and once a slurry wall is constructed and confined the source, then you can deal with the groundwater using a pump and treat method. You just pump the groundwater. You place the pumping wells in such a way that the entire contaminant plume is intercepted. It can be one well or multiple wells if it is a wider plume, and you remove the water, take it out and treat it. Okay, so these are all different uh, scenarios where you can either do a pumping well or you can dig a trench and pump the water from the trench. if it is a shallow aquifer. Okay, if it is oil, if you find oil floating, like I have depicted in some of the diagrams, dealing with just water is not enough. Like I said, first of all, you have to remove the oil out. So there are different oil recovery systems in situ, dual pumping mechanisms where the oil can be pumped out first and then the water, and you can do it sequentially also. So this is some of the uh, images of pump and treat, the effects of pump and treat on the aquifer. So this is a large contaminated zone. It's a DC dichloroethylene plume where you will see that there is a high concentration, low concentration far away, high concentration close by. And if you start doing the pump and treat with capture wells closer to the source, you'll find this is the flow of the groundwater within the capture zone. And very soon you'll find that the concentrations are, I mean, when I say soon, it again depends upon the contaminant. Some of these pump and treat systems take about 10 years to completely remediate, or more also sometimes, depending upon the aquifer, depending upon the contaminant. Okay, so these groundwater remediation are a long term, it takes a very long time for complete cleanup of the aquifer. Okay, it cannot happen overnight. So there are a lot of other issues, right? Pump and treat cannot, it will not be successful. Sometimes there is a rebound of the contaminant when you stop and start your pumping operation. So uh, then comes, as I told you, it's not enough if you remove the oil and treat the groundwater. There is a lot of oil trapped above the groundwater also in the vadose zone or unsaturated zone. So that vapor also can be very dangerous because they can go up. Many sites in US, a lot of people who built their houses in contaminated sites had huge health issues because the vapors coming from their basement. In US, often you have basements, right? And kids are often playing in basements. That is a very typical US home. And so when contaminated air gets into the basements, there is a huge exposure. There is a huge risk associated with the vapor intrusion. Very common problem, and people have dealt with it in US. Uh, so we have to take care of the vadose zone, the vapors in the vadose zone. And also sometimes they also use to remove the volatile compounds from the groundwater by pushing air through the aquifer system. They remove the volatile compounds which are present in the water, basically stripping the groundwater by the volatile compounds, stripping them of the volatile compounds and capturing the vadose zone volatile organics and the volatile organics coming from the groundwater. And then these gases are burnt in a system in a controlled manner outside above the ground. So volatile compounds are easily removed through this method, both from the aquifer and the vadose. So then there are other techniques. If you want to do bioremediation or chemical remediation, you have to do everything in situ. Given the magnitude of the problem and the depth of the aquifer, its excavation is not always a solution. You have to deal with the contamination in situ, where you inject, if you want to do chemical oxidation, you inject and then you wait in the plume, you give enough time, residence time for the chemicals to interact, and then you monitor what is happening downstream. Okay, or you collect some of the chemicals. If you don't want them to be lingering, you collect them from the downstream well. And for bioremediation also, you may need to optimize or accelerate the bioremediation by injecting some organic food source for the microbes so that they can grow in large numbers and they can bioremediate the contamination like oil or solvent in the groundwater. So a lot of in situ bioremediation techniques have been done in many projects in the Western world. So this is another schematic. So you sparge not only chemicals, microorganisms. If you want to induce aerobic bioremediation, you have to inject a lot of air, compressed air, compress using compressor, so that bioremediation is initiated. And if it is not if it is not complete, then they do a recirculation, okay, so that it happens. So there are a lot of other techniques. I don't want to tell about all of that, and I think we are almost at 9:15. So electro metals, when there are metals, people have tried electrokinetic remediation. Um, Phytoremediation has also been tried, not a lot, uh, but for organics, but for metals, plant uptake has been reported. This is for very shallow systems where they pump it out and do an artificial constructed wetland type of remediation, again using plants. Poplar trees have been used a lot for phyto extraction, but these are long term solutions. So you have to do some active remediation like air sparging, soil vapor extraction, and then whatever is lingering in the groundwater, you can leave it for phyto extraction. You cannot directly apply phytoremediation to a very highly contaminated site. So this is like a snapshot of what has been happening in the Western countries. This is the US data. So Superfund sites are the sites where the government is funding remedial action. And what technologies have they been using? So pump and treat, just pumping the water and doing it ex situ uh, is a quite an energy intensive process, right? You have to be pumping non-stop 24 by 7, 365 days a year for several years. So it was highly energy intensive, and you can see that US also moved quickly from pump and treat. The number of the percentage indicates the number of superfund percentage of superfund sites doing pump and treat. It has reduced drastically even by 2000. And the other technologies like in situ treatment, in situ bioremediation technologies, okay, they are all on the increase, because one thing is cost, energy, and effectiveness also. Okay, so as the concentration comes down, pump and treat is not so effective, and it's a wasteful use of energy. Okay, so there are other treatment technologies which we have not discussed. Some of them we have discussed, as sparging, bioremediation, dual phase extraction is like oil and water extraction. Permeable reactive barrier wall, I didn't cover here. It's basically a barrier wall to stop the migration of the contaminants, and that also acts like a remediation barrier. Phytoremediation, chemical treatment, in well air stripping. I will see that air sparging has been in many sites that has worked. Of course, in solvents which are volatile, uh, air sparging is simplest. They strip the volatile compounds and burn it outside. Bioremediation is next. Okay, these are all in situ. All you do is drill a lot of wells, you design it, you inject what the chemicals or the air or the nutrients, depending on the situation, and you let everything happen in situ and you just monitor. Okay, so these are kind of semi-active solutions. So a lot has been done in the other countries. In India, not so much. These For a long time, we have only been reading about all this. We have not witnessed any active remediation in India, uh, except like the one which we got involved in North Chennai. I showed a pipeline spill where we were directly involved, and so we could force it went to NGT, and so they had to do a remediation, and it is the first remediation which happened in the country. We have to do this in spite of the cost. I think it is important when a site is contaminated, the polluter should pay or the government should pay, because all these are huge human health and life are at stake. Many of these NAPLs are suspected or known human carcinogens, very, very low permissible levels in water, 1 to 5 microgram per liter, right? That itself is a toxic concentration. Whereas the concentration of chemicals can go as high as 1,000 for benzene concentration, right? So there is, it is important that we take care of these contamination. It is important, even though it is costly, it has to be taken up. And there's a lot of sensitization has to happen at the government level, people level, to ask, to demand for these contamination. Okay, and these are like inspiring stories, real stories. These are like movies which came out probably about 10, 15 years ago, maybe, but still very relevant. Erin Brockovich, Julia Roberts fights for chromium, a hexavalent chromium site. Civil Action by John Travolta. You should watch these movies. They're all about groundwater contamination and how people's movement had made a change. Even real life, we have a lot of stories. I think uh, in Michigan, there was an academic faculty from Virginia Tech. He led the mission against le- it's funny. He led the mission against lead contamination in pipelines in Michigan, right? So and he made the government, the people aware. The government was forced to initiate actions and regulations for lead contamination from old pipe. And it's really nice to see an academician take that role of an activist and make things happen for the people. So it's a learning for all of us. We just can't stop with doing research. It's important that we voice our opinion, not single person or groups like this. Single person will not be heard, but groups like this can definitely voice your opinion. It will be heard, and justice will be done, and lives will be saved. Uh, that's it. I think I will stop here.
Thank you so much for that comprehensive presentation. So we have been having about more than 150 people listening to you